It just takes a couple lines of code to get your character to chase the mouse like Godot. I'll go over the most common way for your game, as well as providing 10 other examples when the common way just doesn't cut it. Plus, explain what the heck Normalize is and why you should use it for your AI movement. So before your characters can start chasing the mouse, you're going to have to figure out where that mouse is, the position-wise, in the game. So the most common method to use is the get global mouse position. It's already built within Godot, so you just need to tell the character to move to that point that is given by the function. Let's set up a quick scene so I can show you how it works. Okay, so you have your new scene in Godot, and I'm going to make a 2D scene. So you have your node 2D, and the first thing I'm going to do is I'm going to create the character. So I'm going to do a sprite 2D, and then in the sprite 2D over by the texture, I'm going to assign it this icon so we can see it. And then I'm going to click this move tool, and I'm going to move it to the middle of my scene here so that I can see it. But it's pretty big, so let me shrink this down to about half. Okay, so we have our character in the scene. I'm going to save the scene. It's going to ask where. Let's set it up as the tutorial scene. Okay, now in our sprite 2D, we're going to create a script. Name it whatever you want. I'm going to keep it tutorial and create. All right, so we have our extend 2D node, and what we need is we need to get information from the sprite. So hold down left mouse button, hold down control, drag it over, and then you'll get the sprite information here. So we're going to keep it sprite 2D, that's fine. Now what we're going to do is get the mouse information, like where the mouse is within the scene. So we want to do that every second or every frame second. So what we're going to need is the processing delta function. So do function underscore process delta. This is built within Godot to check what it needs to execute every second. So handy dandy, don't need to worry about that. And in here, we're going to make a new variable mouse position. And that is going to equal our new function, get global mouse position. Tab over to fill it out. So now what this does is this function is, pull it up, it returns the mouse cursor's global position relative to the scene, essentially, or canvas layer, which is exactly what we need. So we need to now get the sprite's position and the mouse position and tell Godot how to get from point A to point B. So what we need to do now, save that, is to get the direction of where the sprite needs to go. So we're going to create another variable, and I'm going to call this one the raw direction, because later on I will explain the difference between the raw information and then normalizing. So raw direction equals, so we have our mouse position, and we're going to minus our sprite 2D dot global position. So essentially what this does is it's going to get the global position within our scene, similar to this global mouse position, but it's going to get the global position of our sprite 2D within our scene. And when you subtract it from the mouse, what it gives you is the direction facing it. So here's the mouse position. Here's the sprite position. If you subtract it, it's going to point an invisible arrow to from the sprite to the mouse. So that's why we subtract it. So subtracting is all about getting that direction. So now that we have the direction, the next thing we need to do is to tell Godot to send our character or our sprite in that direction towards the mouse. So we can do that by doing sprite 2D. So take our sprite character, change the global position of that character, and we are going to add the direction, raw direction, times delta. So what this is saying is that we have our direction. I want you to add this direction over time, and I want you to add it to the position, so it's going towards that position. I guess if you minus it, it'll probably go away, which would be interesting. Now I'm kind of curious how that works, but let's play this first. And so it should be, yep, so the mouse is now going towards or sorry, the character is now going towards the mouse because we have that plus. Now, if I switch this to minus, I wonder if it goes away. I'm assuming it does. That'd be funny. Yep. It's like, no, and it's gone. So, yeah, if you minus, it goes away, and if you plus, it goes towards. Nice. But you'll notice that if I play this again, that the further away the mouse is, the faster it kind of gets to the point and then slows down before it touches the mouse. And maybe you don't want that. Maybe you want consistent movement. When you do this kind of raw direction like I was talking about, you can get some jitters. Like the closer it gets, it kind of the sprite kind of freaks out sometimes. And so what we do to fix this is called normalize. So let's do that. And it's a function built in Godot, very handy dandy. A lot of these things are built in Godot to help us do that. So when should you use normalize? Like, how does it work? Well, if you go to the documents, it says it returns the result of scaling the vector to unit length and equivalent to blah, 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 return 0, blah, blah, blah. So really, to put that in terms that I understand, is that it's going to set the distance or give you the pure direction of the vector 2. So not just like how far something is, it's going to point an arrow to the thing, and it doesn't matter how long the distance is. You can have a big arrow or a small arrow. The distance or the length is still going to be 1 when you normalize it. And that creates the consistent movement direction from point A to point B. Like I said before, if you don't normalize it, the distance is going to have different arrow lengths. The higher the value, the further the character has to go, and therefore it's going to get there faster. But if you want to make it consistent, you normalize it, gets that length down to 1. So to see both of them, so we can see the difference, I'm going to create a second sprite, and we're going to apply the normalize with it. So I'm just going to duplicate this. This top one, I'll keep it that, and then this bottom one, let's call it... actually, let's do colors. Green sprite, and then we'll do red sprite. This is going to break the code, but that's okay, because I'll colorize them so we can see. So we're going to change this, delete that, reconnect. Whoop, see, doesn't like it, because it's like, what are you trying to call? Click, control, drag, red sprite, and then now I will make this shorter. Red, red, red. Okay, I don't like that. And then now we'll do green. Get that. Okay, so now we have our red sprite and our green sprite, and I'll color these. Let me move the green one a little bit over. So if we go into our visibility, modulate, let's get some colors. Okay, so this one's green, and then red, visibility, modulate. Let's get some red. Okay, cool, save that. So now we have 2 different colors, so we can see it when we play it. Now, this information is going to be the same. The thing, though, about normalizing, which makes the movement consistent instead of that speed up, slow down, depending on the distance, is that we're going to make the distance or the length equal to 1. And to do that, for our second green sprite, we are going to say, we are going to make a new variable. I'm going to call it var, and this is our smooth direction for our green dude, and it's going to be equal to, so we're going to do that same thing. We're going to get the mouse position minus green dot global position, because we're still doing the same thing, but now we want to normalize these values. And to do that, we're going to put this information in a bracket, and then we're going to do dot normalized bracket. We got to call this again green global plus equals, and this time it's smooth direction over time. So save that. We're going to play the game, and the green's not moving. Why is he not moving? Ah, he's not moving because there's no speed. So right now, smooth direction, delta, it's just, I guess it's just giving a 1, but we need it to travel over time and a speed. Because right now, beforehand, the speed was dictated by how big the direction was, but now we need to call it. So we'll do variable speed equals to, and we'll say 200. So we do smooth direction over time at this speed. So if I play this, it should work. There we go. So now we see the normalized one, which is green, is always following the mouse at a consistent speed. Whereas the red dude, he goes faster the further he is away from the mouse, and he slows down the closer he is. However, the normalized one is just consistent. Some frequent ways that the get global mouse position doesn't work is if the mouse is captured, maybe it's hidden, maybe you're on mobile and there's a touch screen, so there's not actually a mouse, or you're using a grid formation, or you could be using a 3D project. All of these have mouse informations, but you have to get around it by using different functions. And I cover that in the project below, so you can just download it, experiment, and see if what I have set up works for you.